Let us solve differential equation which is called separable differential equation, which is of the form y prime equals h of x times g of y. Now how do we solve this? So these are the steps, and I'm going to show an example in solving how do we execute these steps. The very first step, the step one, is write down the differential equation in this form, which is y prime equals h of x times g of y. If the differential equation is not already in that form, you need to convert this. Or in other words, which is also can be written in the form of dy over dx equals h of x times g of y. I think this would be most useful in solving it. Now, what is the step 2? Step 2 would be, once we do that, then we are going to rewrite the differential equation in the following form, which is we are going to group all the y's on one side and we are going to group all the x on the other side. How do I do that? So I have dy, then I'm going to bring the g of y this side, which is going to be 1 over g of y, and is equal to h of x times dx, right? This is a very important and crucial step. Once we do that, then the next step, which is the step 3, would be integrate, right? So how, if integrating both sides, so which means we're going to have something like this: integral of dy over g of y equals integral of h of x times dx. And then the next step would be to simplify this differential, the solution to this differential equation, which would be of the form some sort of a function f of x comma y is going to be equal to this arbitrary constant. If an initial value is given, then we can figure out what this constant would be, but if the initial value is not given, we can leave as is. And that's how we solve variable separable method. Now let's take a look at an example in solving this variable separable method. So let's take a look at this example 1. A very simple example, which would be y prime plus x over y equals 0, right? So there is no initial condition given. This is just a differential equation. Let's see how do we solve this. So I'm going to do the step 1. If you remember, if you recall our step 1 is to make sure that the differential equation is written in this form, right? So let's do that. Let's see how do we do that. So if I do that, then you see that I have dy over dx equals negative x over y. Now we are going to step 2. The step 2 would be to group all the similar variables in one side. So now this is our step 2, which is going to be something like this, right? Which is what we are going to do now. Now, how would I do that? So if I simplify this, you agree that I'm going to have y times dy on one side. On the other side, I'm going to have x dx. Now the step 3 is very simple, it's just integrating. So if I integrate both sides, I'm going to have integral of y dy equals negative integral of x dx. Now this is a very simple integration, and if you integrate that, we are going to have y squared over 2 equals negative x squared over 2 plus that arbitrary constant right there. And now if I further simplify, then I can simplify this into x squared over 2 plus y squared over 2 equals c, where c is the arbitrary constant. C is the C is an arbitrary constant, right? And that's how we solve this very simple differential equation. If you really want to, you can take it to the next step, which you can just say, which simplifies into x squared plus y squared equals 2c. Or even if you want, you can rewrite it this in the following form of x squared plus y squared equals c1, where c1 equals 2c. And this would be the solution to the differential equation that is given to us. And that's how we solve the separable differential equation using variable separable method.